This Visual Basic script was uploaded to VirusTotal just a couple of days ago, and since then it's begun to slowly get AV signatures, and vendors have begun detecting on it. At the moment it's still quite low, it's only sitting at about 11 out of 60 vendors, but that doesn't mean to say all of these vendors are not going to detect this malware. Now the reason is because this is got behavior that a lot of these vendors are going to detect on. That being said, this has gone to a lot of lengths to try to remain undetected on endpoints and try to remain hidden. But let's dive into it a bit further and see what we can unravel. So first off, if I open this up with Notepad++, you'll notice that it is masquerading as the winrm.vbs script. Now this is a legitimate script that's present on Windows. Let's see if we can spot the difference though. I'm just going to quickly skim through and you tell me if you notice the difference. Is there a difference? Let's take a bit more of a peek at this. First off, what I want to do is I want to find the legitimate winrm script. So if I type winrm at the search bar, I'm going to get the winrm cmd executable. Under this, I will find the legitimate winrm VBS script. So let's open this up in Notepad++. Now that I've got both side by side, there's very minimal differences that you can spot with the naked eye. Now there's a few different tools that we can use to diff these two files, such as the diff tool. In this case, I'm going to use the compare plugin for Notepad++. So if I compare these two files, even though the encoding's slightly different, what I'm going to see is the differences between the two. And besides some of these MS XML version 3 and version 6 differences, you'll notice that there's not a lot. On the right-hand side, we have the comparisons, and that seems to be different here, with the difference only being the encoding used for the apostrophe. Down here, there seems to be some version 6 being changed. Here, once again, the same type of stuff. And then down the bottom, there is actually this WScript shell getting environment strings, so System32 and Syswow64, which is a bit interesting. However, the key thing that we actually want is right at the top here in this second section. You'll notice that there's all of these characters and random strings that don't make sense. And that's because all of these numbers are actually going to be converted. So what that means is if we look a bit closer, right down the bottom here, there is this melodiosamante, however you pronounce it, there is this method or this function. What you do is you pass a value to it, and then from that, what that actually equates to is the char value of that ASCII character. What it's doing is converting to ASCII characters. Despite this, what we actually want is this Lanara string down here, because it seems like a method escuro is going to be used to essentially send a GET request to whatever is created by these variables, and then execute that with this execute global command here. And then it's going to quit WScript because it's launched its next process, and that's it. That's all this is used for. So this is a downloader and a launcher of particular malicious code. The easiest way for me to actually get this information is to run the malware. Now, I don't want to run the malware and have it communicate back and invoke something in memory. I just want to know what it's getting. So what I can actually do is see where it's going to be fetching this from. And it's going to be fetching this from this El Hanura string. So what I can do is change this and do a wscript.echo for this El Hanara. Now we've effectively neutered the malware, so it's not going to go off, get that, and then invoke it, because it's not going to be able to, but it will go off and it will print back to me what it is formulating. So now if I go ahead and run this malware, you'll notice that I get this Windows script host, and it's got this particular URL where it's fetching that next stage from. Now, the problem is, during analysis, this had already been taken down. However, there is actually some analysis that's been done on the VirusTotal side of things that helps us find out what was contained here, based on what it's going to execute. So if we look at the behavior of this on VirusTotal, we can actually see the process tree of essentially what happens. After it goes out and it creates that process and executes it, there is this particular script that's going to be run. Now, I want to take this script and do some analysis on it. So let's just inspect this element here. And what I'm going to do is I'm just going to expand out this to make sure that I have the entirety of the script. And I'm just going to copy what's contained within here. And I'm going to throw that into CyberChef. So now we have kind of the next stage of what's going to be invoked. But this still doesn't help us. We have to do some analysis on it. So let's use regex and let's get base64, because that's what we're looking at here is a base64 encoded string. And we can tell that from this from base64 function. Now what I'm going to do is I'm just going to take the alphabet mentioned here and I'm going to make that into the regex. Then I'm going to say I want anything that's maybe 30 and wider that matches these kind of characters, because that's going to extract the base64 string. Now in this case, I'm going to disable this and just make sure that it matches, and it does. And so I'm going to go list matches. Now if I do this and I go from base64, it still doesn't make a lot of sense. It looks wrong, and that's because it is. We actually have to step back a step. We can go back to highlight matches and look at what else it's doing. So it's then going to replace all of the DG tray entries with the letter A. So that's easy enough. Let's take this and we'll just recreate that operation. So we're going to take this, we're going to find anything that has that, and we're going to replace it with the letter A. Now we're going to do the list matches again, and then we're going to do from base64. Now you'll actually begin to notice, besides the null bytes in there, which we can get rid of, let's get rid of these bytes. We're just going to use remove null bytes. Now we can actually see that next stage. And this is exactly as if we had just looked on VirusTotal, what the next stage of the malware is going to be executing. Now this is where things get a little bit more interesting. So you'll notice that this actually goes out and fetches an image file. Or is it an image file? It's pretending to be an image file, and it actually is. So if you run a scan on this, you will come back with this beautiful image. The author here is a fan of Death Note, and probably the letter L, the character L, that's the alias of the detective who is an antagonist and is trying to have his real identity hidden throughout the series. I guess this person trying to remain undetected, maybe a little bit of a subtle hint with that picture. But what we actually have is steganography. So we can actually look at what else is going on in this PowerShell script to see what's happening here. So there is that image, but at the end of the image, there seems to be this base64 star and base64 end delimiters. That's a little bit interesting. If we look at the response, so this is the raw hexadecimal value of that PNG file, we can actually run a search for base64. And right down the bottom, there is this base64 underscore start. So this looks like a large string. So I'm just going to take this base64 string. We're going to clear this, and this will make the next stage of what we're analyzing. Now I'm going to make sure that I have the whole string. I don't think I did. Nope, I did not. Definitely did not. So let's try to grab everything. And this looks more likely to be everything. Yep, so we've got base64 end there, which is a good sign that we've got everything between the two delimiters. So let's go ahead and remove this. And now let's change this. You'll notice from base64, if we use that operation using the standard encoding scheme, or alphabet, I should say, this will actually make a PE file. So you will notice the MZ header, and it has been detected as a portable executable file. Now, we do need to understand a little bit more of what's going on. Once it gets that base64 encoded string, it's going to decompress that, reflectively load those bytes, so the PE file, and it's going to be getting a particular type. Now, from that type, it's going to be getting a particular method called VAI, and then invoking that. So there's a good chance that this is going to be a .NET binary, and it's going to be invoking that particular method. It's also going to be passing it some parameters. So in this particular case, it looks like it is a reversed string here. So maybe this is meant to be HTTPS and then this URL. Let's see whether that comes up anywhere, and let's take this portable executable and do a bit more analysis on it. So I've gone ahead and got the next stage downloaded from CyberChef and named it malware.bin. Now I do have PE Studio open, so I'm just going to drag and drop this in there to get a bit of an idea at a glance. And you'll see that it did have the name system.management.automation.dll. Under the debug string, there is this cryptors and tools, which is a bit interesting, as well as the mention of system.management.automation here as well. kind of funny that they have the debug string still left in their project, and it does look like this is created with .NET. And while Pestudio is coming up with more information about what this binary is, we are going to just try and open it up in dnspy. So we've got dnspy open, and I'm just going to drag this in. And you'll see that it looks to be added under the system.management.automation. And so if we expand this out, this might actually be a legitimate DLL that has had data appended to it. So system.management.automation, maybe it's copied some particular information from other binaries. We don't really know. But if we look at it, it seems like some of this is just going to be benign code. So once again, trying to remain hidden. But there is this project to automac that looks to be what we had referenced in the PowerShell script that was occurring. So let's just go back and double check what we saw. So after it gets the type project.that.vb.home, it's going to get the method vai. We've got this, we've got home, and if we decompile that, it's going to be getting the .method.vi here. So this is actually what we've got. It looks like it's going to be specifying a particular executable name that's been passed to this method, .exe, and maybe this is being injected into. Maybe this is where the code is being injected into. Because if we look, we can see stuff like read process memory, ZW unmap view of section, virtual alloc x, and write process memory, which is all likely indications that code is going to be injected into this particular process. Taking a look in what we had here, it does look like it's going to be passed the name regasm.exe. So it's likely going to inject into a legitimate version of regasm.exe. And if we go up, we can actually see that there is a process created for regasm.exe. Now, regasm is the legitimate binary used for registering assemblies on Windows or with a .NET framework. And so what this means is that this should always be passed an assembly in the command line. But in this case, there is nothing passed to it in the command line. So once again, something a bit interesting. So this is going to go through, and those bytes are going to be written into this process memory. Particularly, it seems that the bytes that are going to be used are based on what's passed from this URL. So we can actually see it here where it does the string reverse. So that gives them the URL, and then it is downloading that string, and it seems that based on what it downloads is coming back into a char byte array that's then going to be put into the process memory of regasm.exe. So we could actually find out what this is. So I've once again scanned that particular URL, and what we actually have is another base64 encoded string. This looks like it has been reversed as well. So what we're going to do is we are just going to paste this in. We are going to reverse this using CyberChef, and then we're going to once again do from base64. Now this looks like another PE file. So let's download this and see what we've got. So using Detected Easy, we can see that this is a .NET binary as well. Also 32-bit. So let's throw this in and see what we have. So this has now got this name Marks RW1W1990. And if we expand, we can actually see my and stub. There's not really a lot of obfuscation here. In fact, there's probably none. So if we take a look at what's in here, there are specific configuration details. There seems to be this main method. There is the settings for this malware. So it does look like you've got host, port, key, SPL, USB number, and install directory. And these are coming from these particular base64 encoded strings that seems to have a key value here. So we could actually probably go ahead and decrypt these strings as well and see where they wind up being. And so if I go back to the main method of this malware, it does look like it's going to be performing a sleep function first for the thread, and then after that, it looks like it's performing some sort of decryption on the configuration details outlined within the settings class. So the strings seem to be base64 encoded, and after that have some sort of encryption going on so that they're not there sitting in plain text. There also seems to be this mutex, which is likely going to be used to ensure that multiple instances of this aren't run on a system. If we dive deeper it actually does look like this is used in the decryption function as well. So the decryption function itself seems to be getting the Original managed class of .NET, and this is an older, more redundant class that's being used here, and it's computing an MD5 hash. Now that MD5 hash in itself is then being used as the key, so it's being copied to this array twice. So it's the MD5 sum twice that's then being used as a decryptor in the following functions. And it's using a mode of ECB for the encryption, but this isn't really standard AES encryption that's going on here, because AES encryption nowadays is going to be using padding and it's going to be deriving keys as opposed to just getting the MD5 hash of a static string. So using tools like CyberChef, we may actually experience some issues trying to create a recipe that's going to decrypt these configuration details. So what I've done is I've just opened it up in dnspy, the 64-bit, because this is a 64-bit executable now. And I'm just going to run the program, except I'm going to create breakpoints so that I can skip over a lot of the stuff that I don't need. I know that this is going to, I'm in at the main method. So what I'm going to do is I'm going to create a breakpoint before it hits this sleeping method. And then I'm going to step over and begin to uncover these configuration details. So if I just run the malware, straight away it breaks as soon as we run it. I'm going to hit continue, and now we hit that breakpoint there. Sorry, I'm going to set the next statement as the first settings unveiling, first decryption of the settings host configuration details. And now I'm going to hit step over, and we can begin to see that it uncovers. So we do have this marks rw1 new 9090.duckDNS. So this is using some sort of dynamic DNS service in order to resolve a particular IP address, which is going to be the C2 in this particular case. Now we can step over. It looks to be on port 9090. Step over. The key it's using is 123456789, and that's going to be used probably in the command and control traffic. And we step over. So it does look like there is this name XWorm So this is a bit interesting. Maybe we've got more of an idea that this malware that is being deployed is XWorm. And we step over that. The install directory name is going to be usb.exe. All interesting things. We can actually step over that, and now we can see it's going to start resolve the environment variables. So it's going to be creating the malware and setting up likely persistence within this app data roaming directory. And it does look like this is going to be using the startup folder directory based on this string here and specifying a link file. So the link file is going to be the persistence in this case that it allows to run at boot. So this does look like it is more than likely the XWorm that is being deployed by the end of this, connecting back to that command and control infrastructure. And if we look at some of these other classes, I think that we will uncover that yes, this is. And so a quick look into the client socket class also gives us information about when it makes that initial connection back to the C2 server. If we scroll down, there is this runtime object that is specified, the value that is being retrieved of XWorm version 3.1. So now we have really good confidence that this is XWorm that is being deployed at the end of that malicious script. So that's it. That's all I wanted to show you. I wanted to show you the script. I wanted to show you how we could compare differences, how we were able to go about understanding what steganography is involved, and how that's being loaded into the regasm process at the end of the day. So the regasm process will be injected with XWorm here. Let me know your thoughts, feelings, comments, anything else in the comment section below, and I will see you next time.